these traditional ways of protecting data is no longer scalable. And I think that's where the pivot has to be. Welcome to the /podcast, where we lean into the future of IT by inviting fellow thought leaders, innovators, and problem solvers to slash through its complexity. I am your host, James Carman, and today we're talking to Sid Dutta. Sid Dutta is the founder and CEO of Privaclave and a data protection and cybersecurity executive with over 24 years in the industry, including a decade leading data privacy and security programs at companies like Microsoft Gaming, American Express, and Worldpay. He's a certified CISO, a startup security advisor, and holds multiple patents in cryptography, blockchain, and tokenization. Off the clock, Sid is a lifelong cricketer who logged 10,000 runs in U.S. cricket before retiring in 2024, and he runs a South Asian fusion and Bollywood band called Joom 513. That's right. Our area code here. You got to represent. Got to represent the 513. Welcome to the podcast. Glad you're here. We are recording face-to-face. This is one of the first episodes we've done face-to-face. I met Sid. He was on a panel. You were moderating a panel at a conference I was at. I was like, man, this guy's got just like a great voice. So you're going to be like, you guys are going to be like, maybe he should host. You'll hear him. He's got a great voice here. So, but all kinds of cool stuff. So you play cricket. You've got your own band. I mean, you patents in cryptography. Like you're a Renaissance man.
I was like, no. But yeah, the things that I enjoy. So, and of course, cricket and music, these have been always kind of part of my life, and takes your mind off, right?
Yeah.
From the day-to-day stuff. So, they're fun, and then of course you get to meet a lot of people, and have some good time, right? So it's all good.
So cricket, I don't know a lot about cricket. I've seen it. But what people tell me is that, I know folks from India love cricket. And like when you work with folks who are from India, they'll like wake up early to watch the games. And these games go for a long time, right? Like they're like days long. And
yeah, they're like different formats. So traditionally when cricket started, it used to be called test match. It goes for 5 days.
Holy smokes.
Right? So that's the longest version. Then we came down to the 1 day cricket. It's basically a 7-8 hour game. And then the shortest version, which is the most popular at this point, is called T20. It goes for like 3 hours and pretty much like a baseball game.
Like a baseball game. Okay.
Yeah. And then they're like, people come out of work, go to the stadium, watch the game, have a great time, and then go back home. It's not that taking the entire day and you can like take off or something.
Right.
Yeah.
That's cool. Yeah. I was thinking about that, like those 5 days long. In the United States, we use sports as an excuse to get together and get drunk. A lot of folks do. And I can only imagine, like, do people do that for 5 days in India? Or it's a different culture.
Yeah. I mean, I think in other places, Australia, New Zealand, Caribbean, even England, yeah, you basically do that, right? And in India, I think there are some restriction in terms of, what you can carry and what you can buy or what is served in the stadium. Like when I used to go to Eden Gardens or any of the stadiums in India where cricket used to happen, we never used to get it other than, Coke or, soft drinks. But then when I went to London, actually, Edgbaston Stadium, they were like serving liquor. So, of course, we were watching the game.
Sure.
It was a World Cup game between New Zealand and Pakistan. That was the only game I could actually get a ticket for because Indian tickets were all sold out. Right?
Sure.
But yeah, it depends on the venue, depends on the location, and some of the policies that get governed.
So 10,000 runs. That feels like that's a lot. Is that like what's a normal number of runs someone might have as a cricket player? That feels like a lot.
Yeah, I mean, of course, I was never a professional player, so I had always in a semi-professional amateur leagues. So, represented back in India, then it was a very different thing. But coming to US in 2003, and then started playing in 2004 in Arizona first, for almost 14 seasons, and then coming to Ohio, and then representing Cincinnati for the Midwest League. So yeah, it took a long time, and in average, if you were a batsman like I was, and at the top order, you would assume them on a particular season they will average around anywhere between 500 to 800 runs. right, over a span of 4 or 6 months, right? So if you're good at it.
Yeah.
So yeah, and you can probably do the math that how long does it take to get it. So yeah, it was something that I was very proud of.
Yeah.
And that kind of marked my decision to retire, right? It
The
was
10,000
like,
mark. Yeah.
Yeah. So it was like always thinking about that. Yeah. I'll be retiring on my own terms. Of course, nobody's getting any younger.
Yeah.
So, and it takes a lot of toll on your body, right?
I believe it.
The travel, and then playing and then coming, it just takes the entire day and then the rest. When you come back, your knees are hurting, your body's aching, and the following day is crap. So
yeah,
so that was So it takes a while, and it takes a lot of consistency. But I just got done, so I was very glad inside and thought, okay, time to hang up my boots.
And the band, the Bollywood band, is that still active today, or is that something from you did years ago?
That's actually active. So when I left cricket, I thought, it's something I have to continue as a hobby and passion, and to get my mind off from day-to-day stuff. So I launched it here in January 2023.
Okay.
Yeah. So we've been doing shows ever since. Yeah.
Nice.
So it's usually like every 3 to 4 months. We don't perform too much in the city. Usually mostly out of town.
Really?
Yeah, and pretty much all over Midwest. So yeah, it's a great thing to have, and there's a lot of community engagement with that.
Yeah.
So we just launched our latest music video on March 28th.
Oh wow!
So we did a big launch party at Star Bar and Lounge. 150 people showed up.
Wow!
Yeah, so it was good, like bringing people together, and then there's a lot of musicians in the community. So it just is a good thing to discover talent and then perform with them and then have a bond. So actually tomorrow we are having a music video success party. So at somebody's house, right?
Nice.
So there's like all the people who were in the music video or were in the party, actually sang for the band, for the event. They're all coming. So it's just a good thing.
That's cool.
Yeah.
All right. So what, if you play around the Midwest, so what's the biggest city like for Bollywood music? Where do you go and that's like your biggest show?
So the biggest we have done was in Chicago.
Okay.
Right. So it was a North American Bengali conference that was happening. So they brought, artists from India and Calcutta. It was just a pretty big event. And we were one of the 5 bands that got selected all across US.
Nice.
So that was the biggest stage we did, right? I mean, a lot of people. And, but yeah, there's like, if you talk about specific cities, I mean, of course, Indians in population are pretty much everywhere, but the most populated ones are like, of course, Texas and, California, New York. So we haven't been to any of those places yet.
Okay.
Yeah, because obviously there are other bands who are local.
Sure.
Right. So flying out, somebody from Cincinnati, that takes a lot of money, right? I mean, flight, hotel, accommodation, plus the band cost and stuff. But I did perform in Arizona. So after I moved to Cincinnati, I think it was just after COVID. Then they were having trouble to get artists from India, to perform, just because of the travel restrictions. So then they kind of tapped into the local talent and who's out there who can actually travel. So that was one of the occasions that I had to go to Arizona, and then of course Arizona also has a pretty big ecosystem of Bollywood or Indian music and stuff like that.
Nice, that's wild. Okay, well, I mean, you do that also, those other things, but you're also a tech guy, so we're a tech podcast. Maybe we'll launch another podcast all about cricket.
Yeah.
And maybe I'll learn about it and we can do that. But for now, we're going to chat about some technology stuff. So your background, you've been in a lot of kind of big places, Microsoft Gaming, American Express, WorldPay, et al., a lot of big places. Tell me a little bit about your kind of that journey, how you made your way to where you are today.
Yeah, it has been too many years, I guess. I've stopped counting. So right out of college, of course, joined TCS and Tata Consultancy Services, and American Express was our client. So I was working on an Amex project, and my career started in the contact center technologies. So I was writing IVR applications, you call the back of the card number, and then you hear some automated voice, please enter your 15-digit credit card number, or, say, or whatever. So I used to write those applications then. So that's how it started. Then, of course, got into several other areas of the contact center, like call routing, intelligent call routing, computer telephony integration. Then we did some call recording technology, predictive dialing. It's like when outbound dialing happens automatically and stuff. Then, Amex hired me, and then I was getting into more the voice infrastructure stuff. So voice over IP was a big thing at that point. Data and voice, they were converging. So that's what some of the unified communications and all of that was. Then, of course, through promotions and stuff, entirely different things I was doing: enterprise architecture, cloud, CI/CD. The move to cybersecurity was kind of a happenstance. So Amex was launching an enterprise data protection program, and I was tapped into by one of the hiring leaders that, hey, why don't you come over and lead the cryptographic utilities and services. I'm like, cryptography? I'm like, I don't even have a background in information security. Forget about something as core as cryptography. And he was like, yeah, don't worry about it. You'll figure it out. So it was a nervous move, but it was a great move.
Yeah.
And cybersecurity was just getting hot at that time. This was even like pre-privacy regulation, like GDPR, CCPA, and all of these came into effect. So Amex was, very ahead of the game in terms of looking at how they were going to be protecting customer data and, preserve privacy of the customers. So we had a lot of PII and PCI, Amex being so big and, of course, global. So my job was to provide solutions for the teams to protect, desensitize PII data, PCI data, all of that.
What does that mean, desensitize? I've heard you say that. I think I know what it means, but I've not heard it used that way before.
Yeah. So if you're talking about like, how do you render something that was sensitive, entirely meaningless? So if you have something like a social security number or a credit card number, so you transform or obfuscate that data, and the output is something that has no value. Right. So, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9. If that's your social security number, it just got transformed into XYZ 452YZ. It's not even a valid social security number.
So you don't just translate it to someone else's social security number.
Exactly.
It's got to be something
that is, and in a lot of cases, it needs to be obviously, obfuscated so that when you see it, that that's not. But in a lot of other business cases, you actually have to even preserve the format. So a credit card number looks like a credit card number, but it's not a real credit card number. So sometimes you when you look at it, it doesn't look like it has been protected.
Gotcha.
Right? So that's why you get a lot of those false positives, like the DLPs used to catch that. Hey, we just found you've uploaded a PDF document with a social security number. And no, that's a vendor brochure where that they just put a sample social security number. That's not a real one. So those stories that and that was back when I was not in part of security, right? So I used to get flagged about some of those stuff. So that was, and the ways you are desensitizing data is through various cryptographic services, like encryption, tokenization, hashing, and sometimes non-cryptographic. You're doing masking and redaction or suppression, all of that stuff, right? So the whole idea was the data that we are collecting, out of that, the most sensitive ones, we were mandatorily protecting them across every application, every data store. And then we were doing it in a way that you can still use the data. Your queries on that data would, run your reports, the analysts, the batch processes that run every day. They are also able to, function as is without getting disrupted. But the challenge was that it took a lot of time and hundreds of millions of dollars. So it was a big, big program. So I found myself in the middle of a very, very strategic program with a lot of visibility. And that's what I think helped me to take that plunge and then, rise up through the ranks. And then obviously after that, several other jobs. So from Amex to Worldpay, coming to Cincinnati, from Phoenix. That was the job I took at Worldpay as a global head of data protection and applied cryptography. So there were like several things I inherited. And plus, there were like few new things that I had to build out from a program perspective. Then I actually went on the vendor side for the very first time, a product vendor Voltage Data Security was the platform I've been a customer of. And they knew me. And of course, they wanted someone to head product management for that product coming from the enterprise side. So bringing a very different perspective. So I went there, and it was a fascinating 2.5 years with them because I got exposed to, some of the areas that on the enterprise side I was never exposed to, like, sales, pre-sales, marketing, professional services. Engineering was always in my backyard. So that was also something that I always had. But these other things that, how the salespeople are approaching the customers, how the pre-sales guys are being equipped to show the demo or talk about the differentiators. It was a very competitive market.
Mm-hmm.
So, and then of course we were evolving, from this monolithic appliance-based systems to microservices and containers and Kubernetes cluster. And then how do you do this on a serverless compute and AWS Lambda, Azure Function? Those were like cool stuff back then.
Absolutely.
So that kind of phase I actually took the product through. So it was a very wonderful journey until Activision Blizzard happened. And this was like when Microsoft already announced that they were going to acquire Activision Blizzard. So 3 different companies came together, but they were very siloed. And so we had this horizontal layer of cybersecurity. The CISO came in and he was hiring his leadership team. I was, I think, his 5th leadership hire. So joined there as a VP of data protection and privacy engineering. So inherited a lot of the guys who were doing the privacy operations stuff for GDPR, CCPA, but I had to build out some of the data governance and data security aspects there. And then, of course, Microsoft acquired us. We became part of Microsoft Gaming. Then 2024, I decided to launch my company.
Nice. So you've been doing your own thing, the Privaclave, since then, since 2024. Okay, so you've run the gamut. You've seen it all, right? And microservices and all of the things, Kubernetes, serverless, all of the things, and now you're running your own company. So tell me a little bit about what, like, kind of specific itch does Privaclave scratch for folks? I mean, I know security in AI is kind of roughly what I know about it, but tell me a little bit more in depth about what is Privaclave? What problem does that solve?
Yeah, so I think running data protection programs and data security programs, initiatives, and using an array of different products across a decade, what I found was that, one, the industry obviously had been on this false belief of how data gets protected, and the controls that are kind of check the box does something for them, right? So, and even till date, when we speak to a lot of people, then they're like, oh yeah, my data is encrypted at rest. Oh, we have data encryption in transit, using TLS. And they think that from a data security perspective, or when we talk about encryption and all of that, those are the stuff that is actually protecting them. And then more of the focus is on the perimeter side, right? Who has access to stuff? So one, that education aspect of what layers of protection or what layers of data encryption actually buys you what, or what prevents you from what type of attack. So that's a journey, that's an evolution that we still do, right? We explain people that this is what you're getting. But when it gets to the point of that actually implementing data-centric security, right, where you're desensitizing, de-identifying, data at the individual field level, and that essentially gives you that highest level of protection, coupled with your identity access and other network segmentation or network level security as well, that if a compromised credential got to the hacker and they were able to connect to a data store, even after they exfiltrated the data, you basically rendered that meaningless. So your exfiltration incident doesn't escalate into a confirmed data breach or disclosure. So that level of protection has been very, very difficult to implement. And I can understand, why most enterprises don't go down that journey. So they try to kind of take the easy route or whatever makes it frictionless. That's okay. We'll just turn on data encryption at rest. We have TLS, and let identity kind of figure out the role-based access control and all of that. So when I was doing this across multiple companies, Amex had a very different story that we were funding the business teams to actually do the work, right? Because there's a lot of integration work that happens where you're taking a vendor encryption library and vendor SDK to incorporate into your application. Then you make code changes to make explicit calls to encrypt tokenized data. Or then on the other side, after you have tokenized data, how do you make your queries run? How do you make your reports run?
Mm-hmm.
So there's development work on that side. So on average, 6 to 9 months of software development lifecycle per application. And times the hourly rate and number of resources you're putting in. So it was a very, very expensive. The writing was on the wall that this is not sustainable.
Right.
So that's where it happened that as long as the funding was there, people were doing it. The moment the funding dried up, they stopped doing it and then resorted back to those old ways of data encryption at rest and,
sure,
trying to secure the perimeter and all of that. And then, of course, role-based access control and so on and so forth. Same story as I went to Worldpay. We had very little adoption of the solution that, hey, there is this tokenization. This is this service that you need to incorporate. But lo and behold, it just took too long for them. And then eventually that was not prioritized.
Too long, like processing time, or too long to actually implement and make sure they're doing
implement
it
and integrate.
I got you.
Right. So I have an application that takes sensitive data, whether it's credit card number or customer PII, and I need to make sure that the data gets de-identified, encrypted, tokenized before I store it to a database or share it with a third party or put it into a cloud analytics platform. So that effort took a long time. So basically, they was like, no, that's fine. We'll just rely on the platform level controls.
Yeah.
If I put it in the database, we'll turn on data encryption and rest. I put it on Snowflake or any cloud analytics platform, they will take care of it. Or I have it in AWS. So, AWS will take care of my data. So that was like the responsibility of the cloud versus responsibility in the cloud. That shared responsibility model was always that gray area, right?
Mm-hmm.
That what makes it secure, right? Now the cloud has it. Oh, so then it should be secure. But on the other side, yeah, the cloud has certain, controls in place, but you will have to make sure that you implement the controls on the data and how you do, secure application and secure, data ecosystem implemented.
Well, let me ask you real quick. Let me jump in. So I know, like, I was at Vantiv, which I guess bought by WorldPay, some sort of way they became WorldPay.
Vantiv acquired WorldPay.
Okay.
And they kept the name WorldPay.
Okay. Yeah. That's right. Okay. I was thinking it was the other way around because they kept the name. Anyway, while I was there, I did not know a lot about PCI, right? So that's payment card, industry standards. But I know they were very adamant about they had to be PCI compliant, right. and if things touched a credit card number in any way, shape, or form, that device or whatever had to go into the PCI world and be audited and all that stuff. Are you saying that the PCI standards are they're one level of security and they were still compliant even though they weren't doing all these additional things you're talking about? So what you're talking about is above and beyond even the PCI requirements. Right. Okay, I got
so that the line between being compliant and being secure.
Yeah.
Right. And so there's a lot of things that you could do to be compliant, mm-hmm. and the auditors will give you a clean sheet, but that doesn't really mean that you've secured the data so that you will survive a data breach scenario. Right. So that has been kind of mostly the challenge with a lot of enterprises. Their priority is to be compliant first. And then once they have checked all those boxes, then they're like talking about, okay, now how do I secure, my data? So I can be always compliant and check all the compliance boxes, and I still can get breached.
So what do you think the PCI folks, they kind of drew a line in the sand and they said, this is where compliance lives. This is the line of compliance. Were they making just kind of a value decision of like, if we constrain things and tighten it up even further past this line, it just becomes cost prohibitive to get here, or what was the reason to draw the line where you're saying at a suboptimal level to where we could still not survive breaches, even though we're compliant, we would be in danger of having a breach? What do you think the reason for that kind of suboptimal line was?
No, I think you brought up a good point. Is that when your compliance policies and standards are impractical or too invasive or too expensive to implement, you're pretty much either going to be going down the non-compliance path, right? Because there's a business decision, there's an economical decision that you'll have to make. So I think there's the bare minimum capability to ensure some of the fundamental security policies are met.
Okay.
Right. So that is something, and in a lot of cases, people struggle with that as well.
Oh, yeah.
And I would say also that the bodies that are defining the standards for compliance, they probably have not gotten to a point where they have drawn the line that am I actually enforcing a policy to keep those, bare fundamentals in place or implemented, or am I looking at what basically would prevent a data breach, right? And I think the latter is very hard to define because nobody will tell you if you do A, B, C, D, E, you'll be able to prevent a data breach because nobody can do that.
Right.
Because there are so many things and that could actually go wrong. And any one of those failing, could actually lead to a data breach. I sometimes use the Equifax breach example. In that case, there were like a lot of things that went wrong. And it's not that Equifax wasn't compliant.
Right.
So there was a third-party portal, publicly exposed portal of Equifax that actually had a struts vulnerability that didn't get patched.
Ouch.
That was the first thing. So the attackers exploited that vulnerability to get into the Equifax network. When they got into the Equifax network at that point of time was not segmented. It was a very flat network. So it allowed the attackers from moving from one side of the network into the other side. And once they got in, that's where I think most of the crown jewels were actually hosted. They found some credentials on a server, which was hard-coded.
Oops.
And that credential gave access to 51 databases. Now, network segmentation, all of these things are like not a compliance. It's more of a practice, right? And then you talk about zero trust and all of that. So those are the best practices. If you're not doing it, doesn't mean that you won't be compliant, right? So that's one of the example. Now, the credentials being hard-coded obviously was a very, very bad practice, right? I mean, but unfortunately, a lot of enterprises have that in place. They're hard-coding credentials in code and in properties files that are static. So that credential gave access to 51 databases. The data inside the data store obviously was encrypted at rest.
Sure.
But a compromised credential that already has access to the database, data will decrypt out automatically.
Yeah. So for folks who don't know that listen, I don't know if there are people who listen to this podcast who don't understand that, but the idea of encrypted at rest really means if I was like a burglar and I broke into the data center and I grabbed the disk and pulled it out of the machine and took it home, I can't do anything with that data because it's encrypted. I can't decrypt that until quantum comes out. That's a whole nother ballgame.
Right. That's a different one. Yeah.
But as you're saying, if I already have access to the database because I have credentials to get into the database, it decrypts it on the way out, and I already have access to it. So I'm already going through a decrypted path to get to that data. Okay. Yeah.
And then they were in the network for 71 days. Or it was 72 or, the different information. But the trick that they did was they didn't try to exfiltrate everything at once.
Right.
Because that would have triggered some alerts, right? There was like unusual traffic pattern. So for 71 days, they were in the network very slowly getting that data out. And the last failure that Equifax had, that the network monitoring tools, which actually look at traffic that are going out, the egress traffic, had an expired certificate. Because that certificate expired, they could not decrypt that traffic to inspect on it, that what's going out.
Gotcha.
So that traffic went, unfettered and unmonitored through an encrypted tunnel to wherever the command center was, for these hackers.
Oh my goodness.
And that's what, a classic, a domino effect, right? One thing led to the other. There was the last line of defense wasn't there. So everything went wrong. So I think that's where typically where data breaches happen. So from a compliance standpoint, you are telling them to, is your data encrypted at rest? Sure.
Check.
Is encryption in transit TLS? Check. Everything is working, right?
Sure. Yeah.
But still the data breach happened.
Yeah.
So I think those are some of the things. So nobody would draw a line or give you the exact things that, okay, if you do this, you would be able to prevent a data breach.
That's what insurance is for.
That's a probably different podcast, right?
Yeah.
So going back to the point where what's the itch? So where my thought was like, this can be this hard, right? This cannot be this expensive. This cannot be this friction-led. So when it comes to desensitizing or de-identifying data through encryption, tokenization, data-centric security, keep that data persistently protected, no matter where it's being stored or moving or being used or shared. How do you make it very easy and seamless?
Mm-hmm.
You don't have to spend 6 to 9 months of integration and development effort for that. So something just takes care of that. The developers are totally abstracted because developers hate, right, when it comes to incorporating security and particularly encryption, key management. That's a learning curve for them. And they are not incentivized, for delivering secure application. They are incentivized more for delivering new features, right, that will actually drive the business.
Sure.
And when you tell them that, oh, now you also have to do this, that's a distraction. And so those are some of the things that we saw as the adoption challenge.
Yeah.
That why is business not doing this? They all agree in principle that we should be doing it.
Mm-hmm.
But there is a challenge, right? Now, where do I get the bandwidth? Where do I get the engineering muscle? Who's funding this? How do I prioritize between a new feature versus incorporating data-centric security? And 99 out of 100 times, what wins.
Mm-hmm. Mm-hmm.
So that's what, Privaclave was conceived as, that something that would run automatically to do data desensitization that will be frictionless without you having to incorporate any SDKs or encryption libraries, spend 6 to 9 months of engineering and software development lifecycle, and automation is going to take care of that.
Mm-hmm.
So that's what the driver was. And of course, then as AI came in, it kind of pushed the needle much further.
So it wasn't necessarily an AI specific endeavor at its origin. No. It was more of just a general purpose.
Yeah, it was
data.
A business problem.
Yeah.
And that problem needed to be solved. And that's how it is. And just AI just amplified the problem.
Mm-hmm. Yeah.
And now it's obviously, a lot of this implementation or use cases that we are tackling are AI related.
I know some companies struggle with like test data. It's hard to come up with test data. Like, synthetic data only works so well. So there are companies out there who use production like data. You would need to desensitize that. But there's this principle or this concept of like, when I map, Sally Jones, that gets mapped to, Bob Smith. And every time I map Sally Jones to Bob, so it's predictable and all that. Is that kind of a concept? Does Privaclave kind of cover that sort of I don't know what that principle is called, but yeah, that idea, that predictability of the mapping.
The deterministic, capability of like, how do you create consistently the same, I think the concept of tokenization, right? Mm-hmm. So you have this data and that is mapped to a unique token, and that token is unique to that data only, and you can't really have something else having mapped to the same token.
Mm-hmm.
So deterministic encryption or cryptographic tokenization, that's also part of it. And the example that you gave, production data moving into non-production, that's one of the classic use cases for us.
Yeah.
Right? Because test data management has always been a very difficult thing to solve.
Sure.
And a lot of companies are just taking copies of production data and putting that into the dev test systems.
Mm-hmm.
And those dev test systems are not guarded well.
No.
You don't have that same level of security rigor on those, right?
Right.
And that's where it makes it easier for the attackers to go and look for.
Yeah, you don't have to break production.
Right.
You just get into the test environment.
So we make that capability kind of seamless, that if you are essentially extracting the data out of the production, you create the obfuscated version of that data.
Mm-hmm.
One, it's deterministic. Second, it ties the referential integrity. Like if you're joining, different tables, you have one data is actually a foreign key on another data or database or table, then how do you kind of map that? So masking or traditional redaction, they don't work.
Right.
Once you get into those, referential integrity use cases.
Right.
So that's why we obfuscate that cryptographically and deterministically.
Nice. And then like I've always wondered about this. I know that you probably think more deeply about this than I ever have, but like the idea of maybe, okay, one time when I mapped production data to a non-production environment, Sally Jones became Bob Smith, but the next time I'm going to change like the seed for the random number generator or whatever. It's like Sally Jones becomes Samantha Fox, whatever. I'm making up names. She was awesome in the 80s. But like, so you can kind of scope it, and almost is that another concept? Like
that's another concept, yeah, because we call it like the initialization vector, IV, or the noise, nonce, tweak, all of that, right? So there are certain data that you don't need that to be deterministic. You could, be probabilistic as well, and probabilistic is actually a lot more secure because you cannot recreate the same ciphertext, from the same clear text, right? So it changes every time.
It's like putting salt in stuff.
Exactly.
I got you.
Yeah. Okay. So there are certain data elements, you would want to do that. But in other cases, some other data fields. That's why some people used to shy away from encryption because they thought, they won't be able to search on it unless they're adding an additional column with a cryptographic hash that never changes.
Right.
And the hash becomes the way for them to search on that data because the ciphertext is probabilistic, so it changes every time you encrypt it.
Right.
So yeah, of course, there's a lot of that art and science aspect to it.
Okay. So let's get to kind of the meat of this thing, this Privaclave. Now we are in the AI era, and we want to protect the data. What unique problems? I would guess the nature of how we interact with these large language models. It's prompts, it's text, and it's just this big wall of text that's going over. I would assume we can encrypt that going out, maybe TLS, those sort of things, but that's only, those are checkboxes. What are some unique problems in the AI era that we have to guard against when we're interacting with these LLMs that a company like you helps us solve?
Yeah, that's a loaded one because so I think just to kind of take a step back, AI didn't create a data security or data privacy problem, right? It just amplified it. We were living with too many bad practices when it came to data protection. And on the other side, AI also exposed some of those vulnerabilities very quickly that, we couldn't expose it. And then, of course, forget about exposing, we couldn't remediate them. Now, the speed at which the vulnerabilities are being exposed, at that speed, we are not remediating.
Right.
So that's one of the things that your likelihood of a data breach or data compromise has gone way up, right? Because now you can expose the vulnerabilities. And when I say you, the perpetrator or the attacker can find those vulnerabilities that traditionally, they weren't found. And enterprises will not be able to remediate those vulnerabilities. This whole mythos discussion.
Yeah. Oh, yeah.
So people were like nervous about like what it would expose. And then very few companies had access to it. And they were like, okay, even if I got access to that, the speed of remediation is probably not going to keep up with the speed of exposure.
Sure.
And of course, the companies who haven't gotten access to it, now they're like, what am I missing out on? And I'll be late in the game.
Yeah.
Right. So those are all that stuff. So going back to the point is, how has AI changed, the dynamics of data, right? So now we have moved from an entirely deterministic world where applications were scoped under a specific, guardrail, right? This is what it does.
Mm-hmm.
And the software engineers developed the application to access certain type of data, stored the data into select places, retrieve the data from those select places, and process it and share it with, some identified entities. So you actually had a well laid out map of, how data flows.
Mm-hmm.
A lot of companies are still struggling with, finding the data inventory and then the data flows and the maps. Now, what AI did is moved that world from a very deterministic to a non-deterministic, world, right? In that case, now your AI agents and co-pilots are going across data stores that typically humans, weren't going. And a single prompt is basically now exposing, summarizing, analyzing, exposing a lot of that, data. And in the agentic model, some decisions are being made autonomously, right? And in a lot of cases without a human being in the loop. So I think your attack surface changed.
Sure.
The one that used to be able to control through access control and firewalls, perimeter, or even when it came to doing data-centric security, that, okay, these are the data elements I'm going to tokenize or encrypt. But now as copilots and agents are doing the same thing, and in a very non-deterministic way, and you are not able to set that, okay, you can't do this or do that because there are certain decisions that are made on the fly. These traditional ways of protecting data is no longer scalable. And I think that's where the pivot has to be, that people have been looking at this paradigm, which is a lot of inertia that's still there, even in the AI age. I got to discover every data store to find where data is, and that's a point-in-time inventory. But when these copilots and agents are accessing data, the data is not staying in that data store. So it's moving everywhere.
Sure.
So you have to go from this static point-in-time inventory of data at rest to a runtime visibility of where data is moving across humans and non-human identities. And you have to move away from this visibility and dashboarding model that, I'll get all of these feeds into a big alerting machine that gives me beautiful dashboards and graphs for someone to find the signal from all the noise.
It's just like in the Matrix, right? You know, the lady in the red dress, with the little characters. Yeah.
So the runtime enforcement of the policies, that's where it needs to be in the AI world, right? So you can't pre-wire certain things or act as an after the fact, after the risk has already been in place or basically the data has left. You're getting an alert and you're getting some sort of a indication and then deciding what to do. So the enforcement and the visibility, both have to kind of work in unison and at runtime.
Okay.
So I think that's where the challenges at this point, where people are worried about, is the old ways were challenging as well. Nobody really figured out, even before AI, how the attacks are going to happen and how many attacks they will see, and then how to prevent those. They were always, around the clock they were working on it. And nobody got to a point where from a program standpoint, it was so solid and mature. It's always a ongoing, thing that you're evolving and you're getting better and better. But the rate at which AI exposed or created the potential of getting attacked, these old ways were struggling with the old world. And these old ways, obviously are no match with the new world. So I think there's a major paradigm shift where some of the AI governance has to kind of come in play.
So in the old world, I mean, we were doing our best effort to catch things before they happen. And we could rely on, if a human being is writing the code, we can rely on, okay, we specifically coded the thing not to do something stupid.
Exactly.
Now the code is really, as you said, non-deterministic, right? So there's that aspect, there's the non-determinism, but there's also kind of like this much, much more code can be produced at the, it's almost like they can outrun the people who are trying to keep track of this stuff and figure out, is it doing something stupid? So yeah, it's just, as you're saying, it's kind of exacerbating or highlighting problems we always had before. We could keep up more or less with the production of the code at a pace that we were comfortable with. But now that things are accelerating, it's like, whoa, there's just too much going on. The non-determinism is another thing as well. Okay. All right. So what's the solution? How do we get out in front of this and help prevent these issues from happening, these data security issues?
Yeah, I mean, I think obviously there's not one thing, right?
Sure.
There's a lot of things that will be part of the AI governance strategy. What models are being used, how they are being used, and what they are being used for. What data is actually involved in the usage, and then how do we get real-time visibility of what's happening, and not just from the who and what, but also that why aspect, right? When we talked, I think there was a different podcast where I talked about that identity doesn't equal intent.
Right. Yeah, exactly.
Right? So you may have the permissions to certain data stores, and as you are prompting the Copilot, that's inheriting your permissions to go across various data stores to extract information. But the intent behind that prompt, what were you trying to do with that data?
Mm-hmm.
So that is now a new threat, right? Because you just don't understand that, because identity systems will not really tell you that what's the intent, for this particular query. It just says that whether this person who actually made the prompt has access to this particular data or not. And if the answer is yes, then the data will be happily retrieved and presented to the user. But the intent behind it is not known with our traditional system. So I think that's a big evolution that will have to happen, that moving from these rules and policies that have been laid out into our traditional identity access management systems, and not just human identities, but non-human identities as well. But having the ability to analyze the intent at runtime.
Right.
And take action on that, whether there's any enforcement of the policy that needs to be made, that has to be done, at runtime as well. So it's a problem that obviously needs to be solved. It's not an easy problem to solve.
No.
And of course, when there is user experiences involved, there are some friction or performance-related considerations to be made. So I think one thing is for sure that AI adoption will happen, right? It's not no longer whether to AI or not to AI.
Mm-hmm.
I think that boat has sailed. And one of the things that, from a security and governance standpoint, is that how do you implement a governance structure that enables the business to adopt AI in a meaningful way and a responsible and secure way, without blocking, without creating friction. Because even before AI, when security controls used to be disruptive and blocking, that's where the shadow AI, shadow IT aspect started to come, right?
Get around it. Yeah.
Same thing is going to happen with AI, right? Because business is going to adopt, and for the right reasons. But where they're getting challenged is they are not able to fully leverage the potential of the data that they have, and AI to give the outcome and the benefits with the data that they are trying to run through the AI models. The moment you start limiting the usage of that data, the return over the investments on AI is obviously going to get slowed down.
Sure.
Right?
Sure.
And that's where it will happen, is that the governance, if it's too disruptive, too blocking, and it's always a no for a certain thing, then it's a challenge, right? Then how do you enable the business to adopt AI, for the right reasons? And if that doesn't happen, then people will try to get around and try to figure out a way that they can actually, do their job without getting, blocked. So I think the pivot that will happen is where security controls will have to enable business to adopt AI securely and responsibly without getting in the way. Now, that's a easier said than done thing, right? Because one, we have a visibility problem.
Mm-hmm.
And the second thing is, if we have the visibility, the implementation of the controls, how do you do that systematically and contextually?
Right.
Because it's not a rule-based thing that I'll just block everything that has PII or PHI data going out to a LLM, right? And that's what the thing is. Okay, then how do I even use AI if the data that is supposed to go to that? So then how you essentially make a contextual enforcement of the policy, and also based on the intent. Right? What is this workload or this agent or copilot actually trying to do? And if that's a legitimate intent and solving a particular business purpose, that's where your enforcement of the policy will have to act on. Like, should I block? Should I sanitize or desensitize? Should I alert? Or there's
shut it down,
exactly.
Log,
So there's a lot of those, but I think the paradigm is going to be runtime.
Yeah, okay.
That's for pretty much anything, whether you're enforcing any control or not. But even from a visibility and analysis perspective, it cannot be like an after the fact, right? Some telemetry logs getting into SIEM platforms and generating different alerts, and then some analyst is looking at it and then trying to prioritize, which are the highest risk, then escalating that, and then figuring out what controls do we need to put in place. But the data has already left.
Right. Or somebody's certificate is expired and they can't introspect the data, and then it's been going on for weeks. Yeah, that'd be a problem.
So I think the security paradigm will have to be automated, will have to be runtime. And I think last but not the least, has to be frictionless.
Yeah.
Because whether it's legacy workloads or AI workloads, if you introduce friction, then that's where one business won't be able to leverage the potential of AI. And the other thing, they will find another way to do that.
It's funny how many quotes I steal from Dr. Ian Malcolm from Jurassic Park. The nature finds a way. That's what I think of every time I think about like shadow AI, shadow IT and all that. It's nature is finding a way, right? And that's what I always think of. And there's a bunch of quotes from Dr. Malcolm from that movie that I use. I want to talk about the intent thing, because I think that's interesting. And I don't know that people grasp that.
Right.
And the only analogy I came up with is kind of crude. It kind of tells you where I grew up. But when I was a kid, you could, my parents didn't do this. Other people's parents did. You could basically hand a note and if I'm your dad, I could be like, Sid, run down to the store and get me some cigarettes. You're 5, right? But I could just give you a note. And I'd say, hey, Sid, I'm sending Sid to the store to get me some cigarettes. Just, let him go buy the cigarettes. And I give you a couple of bucks and you go buy the cigarettes. And they would just do that, right? But they had a note, right? And that's the intent was, I am letting Sid buy cigarettes on my behalf. So it's kind of that intent thing. I'm using that as my analogy. Now, if I wrote, I'm asking Sid to go buy me some cigarettes, and you show up and you're like, hey, Dad wants a 6-pack of beer too. Person at the store would be like, hold on a second. They'd either say, no, I'm not letting you buy this, or they'd call your dad and be like, hey, Bill, Sid's here trying to buy some booze. He's got this letter saying you're buying cigarettes. Like, what's going on? So that idea, I'm using that as my analogy. I think there's another thing that is almost like a temporal aspect too, right? So, okay, maybe it was true that Sid's dad said, hey, Sid, go buy me some cigarettes 6 months ago. But Sid, put that note in his back pocket, and he's like, hey, I want to take up smoking. So I just go to the store and use that note for 6 months, 10 months, 9 months, whatever. I keep using it over and over again. At a certain point, you would hope that the store owner would be like, this thing's a little doesn't look like this thing's a new note. This doesn't seem recent. I'm going to call this guy again, escalate that, right? I don't know if that's a great analogy. It's the only thing I could come up with at the time when I was thinking through this, but do those concepts, does that translate? Is that a realistic interpretation of what you're talking about when you're saying intent?
No, I think, that actually definitely goes into the intent analysis part, right? Because then I think I was trying to come up with a real world example. I think you probably brought up a very good one.
It's a crude one, but people, I guess it's relatable.
It's very relatable.
If you grew up, we're in the redneck world that I lived in.
Because I think your behavioral history, your access pattern, all of these plays into the intent analysis part, right? So it's kind of like when you, as we are intercepting the prompts and the responses, and we are analyzing, the intent behind those prompts, we're not just taking the prompts as a singular, parameter, right? Mm-hmm. There's a lot of other metadata associated with that particular user that is being tapped into. So their current entitlements, roles, permissions, the data stores that they have access to or have accessed in the past, their current business function, their behavioral patterns with, copilots and agents, right? So there's a mix of things that kind of go into the analysis where you're saying this is the prompt, right? And by the way, these are some of the other, whether it's historical, their current entitlements, their roles, their business purpose, their pattern of data access,
and type of data that they typically deal with based on, what their roles are. So all of those go into the reasoning model, right?
Sure.
So in that case, you're like looking at all of these parameters and then coming up with some sort of an inference that, well, this looks like a legitimate, thing,
Seems
or
normal.
like, there's something that it doesn't add up. Right? In that case, what you're doing is either you're like surfacing that, as like there's a risk aspect to this prompt,
Mm-hmm.
and then you kind of like think about like from there, do you go into an enforcement that like the data that they were trying to access, I'm probably just going to obfuscate it and or mask it before they view it. I'll still allow them to see the data. I'm not blocking that request, but I'm just going to hide some of the stuff that which may have been something that they were like a prompt like, give me the salaries of all the employees in my department, right? Like, okay, I'm from payroll, so I probably should have access to that.
Mm-hmm.
But am I trying to see, what Julie, who sits next to me, just joined 2 months back, getting a higher salary than me? Or my boss is making, how much?
Yeah.
And I've been asking for a raise for the last 2 years. So those are...
Nobody would ever do that.
So all of those things are, possible, right? So I think to your point, yes. So there is this aspect of how long and what has been the pattern, and then how long they have been in this particular role, and the type of access and all of that. So that kind of goes into the intent as well.
Yeah, it's interesting you brought up like kind of the context and the history stuff. So like, I think a lot of people are familiar with this. Amex was one of the pioneers in this of the kind of that anomaly detection principle of like, you normally buy your groceries at Kroger in Fort Mitchell, that's where I buy my groceries. But somehow there's like, you're buying groceries at a Kroger in Arkansas, for instance. Yeah. Amex might call me and be like, hey, James, are you buying groceries in Arkansas right now? No, I'm I'm at home in, Kentucky. Okay, we're going to decline that transaction, those sort of things. So you're saying we need to do that kind of on these prompts and this AI. I mean, there's all sorts of context, right? Like, what time of day do you normally do things, right? What time, what IP address do you normally log in? Like there's a lot of context that we can put into those kind of historical look. And you look for those anomalies that are like, okay, this looks like this might be a little, as you said, kind of elevated risk if it's a different IP and those sort of things. Is that what we're doing?
That existed even before.
Yeah.
Right?
But we're applying it. Are we applying that?
Those are some of the parameters, but I think there's like a lot more, I guess. Yeah, I mean, attribute-based access control, they existed even before we had, AI or the kind of risk that we're talking about. A lot of people are like, okay, still got the same ID and password, but the IP address looks from Russia.
Yeah.
Right? And that's where like, okay, it'd probably be not allowing that. So I think those kind of existed, but that's even if everything matched, right? Your home location or your office location still shows Kentucky, same ID, password, everything matches. The application that you typically access is the same application that you've been accessing. So kind of there's no flag or anomaly in there.
Right.
But then like, how do you now determine the intent behind what you're asking, right? So that becomes a more difficult problem to, kind of understand. Right?
Okay.
Because in that case, of course, you're feeding, the intent analysis or reasoning model with everything else, your entitlements, your roles, your behavioral pattern and your access history and all of that stuff, and particularly the prompt. But then like, how do you analyze that given he has access to the database, he's accessing from the right office or location that where he usually is pretty much 5 days a week. And, he is prompting something that may or may not be benign, something maybe malicious. So I think that requires a lot more additional metadata, across different other criteria, and then you kind of like come up with that. And sometimes it's a hit and miss, right? I mean, you may actually come up with a very false positive type of intent analysis, and then basically restrict him from accessing that data.
Sure.
But I think that's where models are all being tuned and refined for that.
Yeah.
But I think whether it does a great job or does a perfect job or not, that's probably a secondary thing. But having that model in place, this whole paradigm of not only relying on your identity, RBAC or ABAC, but also analyzing the intent is I think the right thing to do. Now, of course, these are going to just get better and better.
Sure. Now, when you mentioned like models, so I know like in the credit card processing, typically how they do that, because they need to do it in line. I mean, when you swipe your credit card, you don't want to wait around 10 minutes for them to like thumb through history and be like, well, let's see here. Oh. You want it to happen quickly. I want to be able to buy my Snickers bar or whatever. What about this idea of trying to ascertain the intent? Are these more like, are we fighting fire with fire in that I'm sending it off to an LLM to try to figure out is something going wrong? I would imagine that would be slow, right? Or are these more deterministic? I mean, I guess they are deterministic. Machine learning is deterministic because it always spits out the same answer. But like, is that what we're using? Are we using more deterministic models, or are we fighting fire with fire using these LLMs and probabilistic models to try to figure these things out? How is this working today?
Yeah, so I think there is an out of band aspect, and then there's an inline, right? So, and a lot of companies, they are probably trying to get monitoring and observation done before they go into enforcement, right? Just to kind of get that. So when it comes to an out of band intent analysis, then you're not restricting the user interaction, right? So you're basically just mirroring, the packets and then understanding and then analyzing it and then surfacing that to, some sort of a dashboard for someone to take a look at, like how my users using copilots or AI assistants and what type of prompts they're doing, and then what type of intent is being coughed out by the models without impacting the user interaction. So sometimes it's a phased approach. It's like, okay, let's just monitor first. Let's not go into enforcement. So in that case, if you're analyzing, depending on the solution that you're using, you could actually use an LLM, whether it's the foundational frontier models and you call OpenAI or, Anthropic or, even like some of the services like AWS Bedrock.
Right.
Or you could actually have something that's local, locally hosted, whether it's a small language model or LLM within your same environment without having to make an external API call. But regardless of that, there is an overhead.
Yeah.
Right? So in that case, until you get to the point of inline enforcement that you're going to do, and basically making decisions in a very quick, time frame. So those are some of the things that will evolve. So that's why inline enforcement, people don't like to do that because it's like, oh, that's going to impact my users. Now, of course, if you have a customer on the other side, you don't want to impact their experience. So I think there's like too many dependencies in terms of when it comes to performances and stuff.
Sure.
Right. How much are we analyzing? What's the compute? My reasoning model is actually hosted on, right? Whether if it's locally hosted.
Yep.
If I'm calling an frontier model, an API, what's my round trip latency, right? So these are all considerations that have to be made before going in. There are certain workloads that people are more patient about, right? And then certain they are not.
Right.
Yeah. So you have SLAs tied to certain, but with the user copilot interaction, like when we type into Microsoft Copilot, it's like thinking, clocking, and we've gotten used to that. It's actually doing something, and then eventually it starts to give me the data. Now, if that intent analysis adds a couple more seconds, whether that's going to be a big differentiator or like a big dissatisfaction or not, that depends on who the user is, right?
Yeah, but it could be just like, day to day, it seems like these things like one day it might answer in 2 seconds, and then the next day it's taking 35. And
exactly.
What's going on?
It's like analyzing and thinking. Like ChatGPT says,
discombobulating.
Like, So I think those are some of the things that business will have to make some decisions in. Like, do I have an out of band thing that doesn't impact the experience, and then still I get some intent analysis, and the point when I make a decision that no, there's too much risk going on there, I have to go into inline enforcement. At that point of time, you're essentially keeping the user, waiting for that enforcement to happen or the intent analysis to be done so that they can do the enforcement. A lot of cases, the intent may not have anything, so they're not enforcing, so that additional overhead may not be that significant. But if you're like, okay, there's a bunch of data that came back from the payroll database with everyone's salary, I'm just going to obfuscate all of the names and employee IDs and the roles there. The salaries can be there.
Yeah.
I mean, like, yeah, you wanted to know how many people actually make more than $150,000 in my company.
Yeah. Do you need to know who it is?
Exactly.
No, you don't.
Yeah.
But you can figure out how many. That's fine.
Correct.
Okay. And are you seeing any, you hear people talking about kind of this idea, you said like small language model,
Right.
like these purpose built,
Specialized.
specialized. Are these starting to kind of come up now more prevalently?
It's actually going to be more. I think that's my thought, is that with the token costs,
Mm-hmm.
that the companies are bearing, it's just going to get so prohibitive that people are going to embark on open source models, and then not just one model. They'll have these specialized small language models that have been trained and tuned to do a certain function very well.
Yeah.
And that's where I think a lot of those, I would say the drive would be to implement locally hosted open source models to cut down on the costs of the tokens.
Right.
Because we're seeing all of these different stories of people shutting down on
$500 million in tokens spent by one company. I saw that. I don't know if that was true or not. Did you see that?
Yeah, of course. And then a lot of, like, even Microsoft, they stopped issuing that, right? So because it's just getting too cost prohibitive.
Sure.
And now you got this whole memes going around that the employees actually cost way less. So all the people that they fired, because the AI was going to do that, like
we're hiring them back.
Hire them back. So yeah, but I think that's a practical consideration that I think enterprises will make to invest, into SLMs, and particularly going down the open source route, because they want the capability to be there, but they don't want that to be at that high price, right? So, and I think there's a lot more focus going to be on training those models that are potentially going to get locally hosted. And the SLMs, obviously, they do a great job, right? For specific purposes, right? I mean, there are models that do a lot of things well, and then there are models that do one thing very well.
Yeah, absolutely.
Right? And I think those are some of the R&D work that typically, and we do that as well on our side when we evaluate different models. They're like, quite a few things are over a period of time. We find that no, they start hallucinating, after a certain point of time, and then certain models are actually doing it very consistently well.
Yeah.
So there's always that narrowing down to one or two, at that point of time. But you're right. I mean, I think you will see a lot more of that happening.
Yeah, I think these large language models, the frontier models, like you're talking about, like they're a very blunt instrument as far as they're trained on a corpus of everything in the world, right? Like, so if I have a model that I'm wanting it to detect these intents, do I care that it knows about Plato and Socrates?
Yeah.
No, I don't. I don't need that, right? I need something much more curated for what I'm looking to do, I guess, and customized. So yeah, I see that. And I don't know why it hasn't really started. It's out there, right? But it's not. It doesn't seem to be very prevalent right now that people are using these kind of specialized models. I wrote an article when ChatGPT, I think it was 5, came out, because they were talking about like choosing which model to use, and I was like, oh my goodness, I'm so excited because maybe we're finally going to get this mixture of experts thing, right? So that you have like one model that says, oh, let me use my finance specialized model to go talk to that. Well, that's not what they did. They just different levels or whatever. Like, I'm going to pick Opus versus this or whatever. I'm just surprised that hasn't happened yet. And I don't know what it's going to take to. Research is being done. It's out there. The concept exists, but from a general purpose standpoint, you just don't see it going on yet. Which I find that weird. I mean, is that weird to you?
Well, it is in one way, because I think from a economic spend perspective, when you're kind of doing some R&D, I think initially most of the enterprises had released some of that budget to kind of start doing it, right?
Yeah.
And then so many tokens that you purchase, and then give every developer a certain number of tokens so that they can start working on it. So I think it got to a point where you came to an inflection point that this is probably not going to be sustainable beyond an R&D exercise, right? Because now enterprises are no longer in an R&D mode, right? In a lot of cases, they're actively using it. And I think the first wave was large language models, which models are doing great. So we'll embark on those. Then we kind of moved into co-pilots and AI assistants. So we kind of like pretty much a lot of enterprises already have Microsoft Copilot or, the equivalent on Amazon and Google. Then the second wave or the third wave would be AI agents, right? So, and as we get to that part, then I think you've kind of moved away from testing and experimenting on these large language models or building certain LLM workflows that I just built a wrapper around an OpenAI or Anthropic. Yeah. In that case, my tokens are already I have, and I'm going to just keep that. And then when it comes to that, you've exhausted the number of tokens, then how much is going to cost you to continue doing that? And then that's that pivot that's going to happen, because there's building one application that is basically a wrapper around an OpenAI or Anthropic is one thing to control from a budget standpoint. And the moment you start moving away to AI assistants and copilots and an array of agents technically using LLMs, you're basically looking at 10 times or 100 times more at that point of time, right? And of course, going forward, we'll have way more agents than employees or humans in any enterprises. And to kind of sustain at that scale and with that cost is no longer going to be there. So I think it's that shift, that where that enterprises are in their journey, whether they are still in experimenting, but in a lot of cases they have moved away from experimentation to certain business processes, still at an assistive layer.
Sure.
But then as they're moving into more autonomous agentic layer, I think they'll have to make that shift, because they've already understood that this cost is no longer going to be something that they'll be able to manage.
I know there's a lot of talk in the market. You were talking about kind of the token explosion stuff that's been going on. Okay, was it GitHub Copilot changed their token-based billing or whatever the other day, and everybody's like, "Oh, I'm done with my month's tokens by 1 p.m. on the first day." And then there's some cynicism in the market right now. It's like, oh man, all these companies they're doing the drug dealer model. They give you a taste, they give you the first hit for free, and then they're going to start charging. Do you think it's that, or do you think is it kind of something a little more innocent in that we're really just all learning our way through this whole thing right now, and I don't know. What do you think? Are you on the cynicism side, or what do you think?
No, I think pretty much every business model has this ability to attract you, initially with a very low entry, fee or potentially a freemium, right? Yeah. So, and then when you like the product, then you want to use it more.
Sure.
Right. But the issue has been that no longer the models are differentiators anymore. Right. I mean, if you look at like with OpenAI, Anthropic, Perplexity, they're like, anyone who's like talking about that we have a better model, I don't think people are worried about that part or concerned about it. I mean, DeepSeek at a fraction of a cost that does amazing, job, right? So I think that differentiation is over.
Yeah.
So in that case, I think it's not that you get locked in, to a specific model just because you entered in a freemium or a free model or a very low, $20 a month or $200 a month, and then eventually that you can't get out of it. So I think I don't see there's a cynicism here, because I think where the differentiator probably would lie is that which of these models or these frontier model providers are going to enable enterprises to adopt AI securely and responsibly, with the right governance in place.
You hear a lot of talk about harnesses. Have you seen that? So that's what they're talking about, like the products that use the models underneath. Right. These harnesses are the differentiators now. Not, as you're saying, I think the models themselves and the capability of the models,
because they've been trained with the same data.
Yeah, it's kind of becoming commoditized.
Right.
Commoditization is happening here. So it's those harnesses, and is Anthropic doing a better job of creating the product around the model,
right,
to help enterprises do it safely, securely.
Exactly, yeah.
Okay. Yeah. I'm with you on that. Okay. This is great, man. We can sit here and talk all day, but we've got to go to our next segment of the show, which is ship it or skip it.
All right.
Ship or skip, everybody, we got to tell us if you ship or skip.
Post-quantum cryptography. You hear people, there's people talking about it's dangerous, right? And the quantum computers don't exist, right? They're yet. I mean, there are some, right? But they're very, very limited in their capabilities. Right. There's not a lot of like, you can't go up to Best Buy and say, yeah, give me a quantum computer. That's not something that exists right now. However, there are folks talking about like there is an issue today. Are we really at a point where we need to be thinking about post-quantum right now? Or can we be like, kick the can down the road? What do you think?
No, I think we should be thinking about it. I think a lot of companies have started to think about it. And yeah, the threat is real.
Okay.
Right? I mean, this is a, no debate, right? That, whether quantum computers will be able to, crack through the encryption, as we talked about, the asymmetric cryptography, the RSA, CDSA, and the likes of that. So it has been proven that Shor's algorithm, has broken them. Mm-hmm. And the panic, I believe, is a little bit, hyped.
Okay. Overplayed
right?
a little bit there.
Right.
Okay.
Right. Because this was something that I had an article that I wrote for Cyber Defense Magazine as well. It's like the encryption apocalypse, that isn't, right? So I think a lot of people are talking about, all of the data that, I encrypted are now the TLS tunnels, it's going to get harvested and then they will decrypt it later, whether it's 5 years, 7 years, whenever they actually get a possession.
So let me make sure the listeners, so I can make sure that lands. Because I do think that is an interesting concept. The idea is you encrypted data. You basically boxed up some data in a way that right now, with state of the art, it doesn't matter if I were to hand you this data and say, here you go, Sid, this is my social security number, but it's been boxed up in such a way that you're not going to be able to open that box. You're like, okay, that's great, James. I'm going to go put this box on a shelf. In 2032 or 2030 or whatever the case may be, I will have a way to open that box later. I will grab that box off the shelf and I will unlock that box. And now I have your social security number. That's kind of the principle. It's that harvest now.
There's a little bit of a caveat to that.
Yeah.
Right? So if I handed you my social security number using an AES 256 encryption,
right,
that may not be true even 5 years later that you'll be able to hand that over, right? Because right now the studies and whatever experiments have been done is that the encryption that has been broken, are the asymmetric cryptography, right? Mm-hmm. Where, let's say, TLS.
Yeah.
So I send a data from my company to another company, over, an encrypted tunnel, and
mm-hmm.
I'm using asymmetric cryptography. I've got the public key, and then it's a private key at the other end. So at that point of time, the data that is going under an encrypted tunnel.
Yeah.
And this harvest now, decrypt later concept is applying to that. When that data is going through that tunnel, I'm taking that encrypted data and storing it somewhere as an attacker.
Right.
So I have a bunch of, encrypted, data using asymmetric cryptography. So what happens when these tunnels is that there is a symmetric key that is used, to protect the actual payload that I'm sending. And that symmetric key is encrypted using public key cryptography,
mm-hmm.
public key, private key. So if I'm able to break the public key cryptography to get that symmetric key, then that symmetric key I can use to decrypt all the data that you have encrypted in that tunnel.
Gotcha.
So that's where what quantum has broken is the ability to decrypt that encrypted key.
Gotcha. Okay.
Now, once the encrypted key has been decrypted, you have the key.
Yeah.
So whatever data was encrypted in that tunnel, now you can decrypt it. So in that case, if the social security number was being sent under the encrypted tunnel with an AES key, and then the AES key was encrypted using RSA, quantum will be able to break that RSA,
decrypt the AES key, and then decrypt all the social security number.
Gotcha.
In 5 years or whatever.
But if I didn't have access to the symmetric key, it doesn't matter.
Exactly.
That's still okay. It's the asymmetric public-private stuff that's at risk. That's in jeopardy.
So once that is at risk, anything that you encrypted with that asymmetric key cryptography, that has been exposed.
Gotcha.
So in a lot of cases where backups, right, or some cloud storage buckets, you are using asymmetric cryptography or to asymmetric cryptography to encrypt that symmetric key to encrypt that bucket or that backup. So if your asymmetric cryptography got broken, you exposed the AES key.
Sure.
So that's where typically the concerns are that, if my asymmetric cryptography gets broken, the symmetric key that was encrypted by the asymmetric key pair, that will get exposed.
Mm-hmm.
And once that key is exposed, the data can be decrypted at will.
Yeah.
So I think that Harvest Now decriptor was that whole concept that I will just hold all the encrypted data with me until I get possession of a quantum computer so that I can break the asymmetric key cryptography to expose the symmetric key, which will give me the access to decrypt all the data that I've harvested. So there's that panic, I think, has been happening. But they're like, obviously, what data actually has a value 5 to 7 years down the line? So those are some of the things that people will, credit cards, no, right? I mean, 5 years,
you get a new number. Yeah.
Exactly.
Yeah.
And Social Security, yes.
Probably a problem. Yeah.
My healthcare data, my medical history, yes. Those are something that's tied to me forever.
Yeah.
So I think there's a little bit of that analysis that needs to be done. Yes, your migration from these algorithms that have already been broken to post-quantum cryptographic algorithms that NIST has already, published like 4 of those. This will take time.
And that's a great place to pause. We covered the data protection problem, how AI reshaped the whole threat picture, and we put Sid through ship it or skip it, but we're not done. We're breaking this into 2 parts. In part 2, there's more conversation with Sid, and then the segment you all tune in for, the lightning round. We'll see you in part 2.
The /podcast is created by Calibrity. The / team is director and producer Ryan Wilson, editing by Steve Baradelli, marketing support by Taylor Blessing, and I'm your host, James Carmen. Thanks for listening.